again. Fingers crossed. All right. Am I recording? Did you guys see me push record? Yes. This is good. All right. So this is the point in time where I have to go back and ask you to do with me a problem that you probably did way back in elementary school. And this has become somewhat of a lost art, the art of actually dividing, because what we do is we generally just use calculators. I got no issues with that, but it does become a problem when we have to learn what we're learning this week. So I'm going to remind you of the long division algorithm, and I'd like you to work along with me. So
copy.flop?
absolutely nothing to do with copy.flop. This is straight up seriously back in like 4th and 5th grade. There was an adult in your life that got paid to try to teach you how to do this. You may not remember who it was. You may not remember doing it. But at some point, someone asked you to do division like this. And nowadays, we've all pretty much just thrown in the towel. And if I want to know what this equals, I'm just going to type it in my calculator and get an answer. But you'll see today why this repetitive process becomes so important, because we're going to do the same steps, but we're going to do them with like x squareds and stuff like that. So here's how the algorithm begins. It's been a while. And by the way, let's just so I can talk vocabulary with you, I would like it if you'd write this down or at least promise to memorize it. The number inside that we're dividing is called the dividend. I'm not, as you know from previous experience, I'm not a huge fan of holding you accountable for the vocabulary. But when I say the words, I'd like you to at least know what I mean. Do you guys know what this fellow out here is called? Nope. The thing you're dividing by is called the divisor. Got it? And there are two more places where numbers can appear. One of them is up here. Do you guys know what that one is called? It's like the answer. It starts with a Q. It's called the quotient.
Dang, I have not gone over this.
And then finally, way down here on some problems, not all problems. Do you remember how there's like sometimes that little leftover number that you can't really work with anymore? Do you guys remember? That's called your remainder. I really don't want to talk too much about that. I just want to get that out there so that when I use those words, dividend, divisor, quotient, remainder, that you're going to be comfortable with that. So, all right. So I'm going to erase this now because I don't want it to be in my way, but make sure you have those words committed to at least memory. So here we go. The way the algorithm begins is we take our divisor and we ask ourselves, how many times can 7 go into 5? And the answer is it can't. And so that's when we extend the number 5, we add a digit to it, and we now call it 59. So we ask ourselves, how many times does 7 go into 59? 8 times. So I'm going to put 8 into my, it's going to start my quotient is 8. Okay. Do you guys remember the next step in the algorithm? We're not ready. We multiply. So at this point in the algorithm, and you don't worry, you're going to get really good at this. We do the thing we added into our quotient times the divisor. Good job, tough. We do 8 times 7. So we're multiplying those and we're getting 56, and we're going to put that right here. And then the next, and Micah just said it really casually, but it's important that we're all on the same page here. The next step in the algorithm is to subtract. Do you remember this from way back in the day? So I'm going to take what was originally in my dividend minus this new answer, 56. I'm going to subtract and I'm going to get 3. What's the next step?
Bring down 8.
Bring down 4.
Oh,
and you hear me say this is where the algorithm resets. What I mean by that is the algorithm has 3 steps. We just did all 3. And now the process is like back to the beginning. And now we reset and we ask ourselves, I'm going to circle these for you, and I'll erase this in just a second, but I'm going to ask you, how many times now does 7 go into 34? And the answer is 4. So I'm going to now bring a 4 up into my quotient, and the same steps that we just did are going to rinse and repeat. So now we take that new guy up in the quotient, the 4, and we back multiply him by the divisor. What's 4 times 7? So we stick a 28 here. We subtract and get 6. And then the algorithm resets again. So you're starting to see what I mean by that, that we come back to this familiar location where we're back to the beginning, back to the beginning, back to the beginning. And I know that we're done at this point because 7 goes into 63 9 times, and there is no leftover. You will not see a single remainder today. I made that choice on purpose. No remainders. If
That's
you
what
get,
we're doing.
God, no.
Dang it.
I'm doing this with you so that here in about 4 minutes, when the real problems pop up, you're not going to get mad at me because you don't remember how many times does this go into this, multiply, stick it here, boom, subtract, drop this. I don't want those to feel foreign when we get to the good stuff. So we're going to do another long division problem like this, and then we're going to get into the algebraic ones. You didn't actually think we're going to do this for like a week, did you?
No.
So anyways, the quotient, or the answer, if you will, is 849. And the fact that it came out evenly is nice. That means that there's no remainder, because 9 times 7 is 63. And you can see that when you subtract, you'll get 0. That's good news. Haley, you good? Okay. Let's do one more. So this time we're going to do 16,027. We're going to divide it by 11. So let's go nice and slow. It's not a race, anybody, okay? We want to make sure everyone stays on board. So the divisor being 11, I want to chop into that dividend until I find something that 11 can satisfactorily go into. And the first thing I see is right here, the number 16. How many times can 11 go into 16?
4.
So I'm going to start my quotient with a 1. And now we're right in there. We're knee deep in the algorithm. Next step is,
11 times 1 is 11.
that's right. Next step is multiply. So we take what's up on top and multiply it by 11, get 11, stick it there, subtract. What is 11 minus 6? Or 16 minus 11? 5. And then we drop the 0, and we are now back to the beginning. And you can see that there's going to be this 3 more iterations of this process, because there's 1 dropping the 0. The next will be dropping the 2. The final will be dropping the 7, right? So how many times does 11 go into 50? What is 4 times 11?
44.
What is 50 minus 44? Thank you. Then we drop the 2, and we're back to the beginning. How many times does 11 go into 62?
5.
5 times. What is 5 times 11?
55.
Subtract. What is 62 minus 55? Bring down the 7. How many times does 11 go into 77?
7.
And what is 7 times 11?
77.
So in this case, I'm going to get another, as advertised. I made sure today, I took great care to make sure that nothing would have a remainder today. You won't start seeing remainders, I hope, until Monday. So you ready for the mathy real stuff?
No.
Good answer. Let's do it.
It's a good answer.
Yeah, because I know when you say no that you're either just being whiny or that you actually mean yes. In both cases, we're good to go. So here's our first one. Our dividend, well, let's start with the divisor. It might be easier for you to structure this. So our divisor is x plus 4. And our dividend is going to be x to the third plus 12x squared plus 37x plus 20. Now, you might not believe me when I say this, and that's okay, but at some point you'll see this correctly. The same steps that we just did, we're going to do again. There's a little kind of modification to how we have to think about it, but it's this goes into this, stick it there, multiply, come down, subtract, drop the next thing, boom, you're back to the start line. So, you ready? Foxy, you good to go? Okay. So when we do this first step, I'm gonna circle a couple of things for you, and this I'll have to say this a few more times. So try to get it this first time, and then you can make fun of the people who keep asking. Here it goes. When I want to know at the beginning of a division problem, I always ask the question, how many times does that go into that? What I want to know is how many times that yellow thing I've circled, x, has to be multiplied to make x to the third. So let's pause for a second. I'm asking you this again, and you don't have to answer this question because it's not going to do us any good. The question is, what do you have to multiply this by to turn it into this? And again, don't answer the question. Just let that simmer. First off, it's not a number, right? If I multiply x by like 3, I get 3x. That's not what I want. It's not 4. It'd be like 4x. What do you have to multiply x by to turn it into x to the third power? I need more x's. I need x to the second power is what I need. So I'm trying to take the outside yellow guy and turn him into the inside yellow guy. Where the confusion happens is people start to look around too much and they lose their tunnel vision. You have to have tunnel vision on just the two things I've circled in yellow. The rest will take care of itself. So when I ask you the question of how many times does yellow go into yellow, your answer is
Yellow.
this many times. Got it? Still with me? All I did was say, I answered this question. What should I multiply this by? Turn it into this. I should be able to put anything on the board and say, I want you to turn it into that. So like if I put a 10 and I said, make it into a 30, you'd go, oh, that's easy. I'll do times 3. If I put an X and I said, make it into XY, you'd be like, oh, that's easy. I'm going to multiply it by Y. If I put an X here and I say, make it into X to the third, you should say, oh, that's easy. I need to multiply it by 2 more X's, X squared. Do you understand that? I'm turning one thing into another by multiplication.
Yeah.
So I can check, I got to erase a bunch of this now. I can check right now to see how I've done by just checking to see if the things that I have multiply out correctly. Let's see. I need a fatter eraser than that. Oh, that's my guy right there. Does this thing times this thing equal what I wanted? Then we've done a good job. That's all you have to do in step 1. We good? Now it's time for step 2. What was the next step in our algorithm when we did this? We're not ready for subtraction yet.
Don't you have to go
Say again.
through everything?
We multiply, right? You have to remember and try to equate this to those first 2 examples that we did that didn't have x's in them. We're at the point in the process now where we understand what we have to, like how many times yellow goes into yellow, but now we have to reverse the process and multiply this by this. Ready? So I'm going to write down here and I'm going to write it in purple for you. I'm going to multiply and I'm going to get x to the third plus 4x squared. So what I just did, let me add some parentheses for you, is I took that x squared that was up high and I multiplied him. This is why we do what we do in the order that we do it in. I multiplied the red number by the purple parentheses. I did distribution. You good? I don't want to press on until I know that we're all okay. So we're good? Okay. The next step, and there's only one really big step left, and it's to do what? Subtract. Try to, again, stay parallel and stay aware of where I am in the process. I'm now at the part where I subtract. So the thing about subtraction, as you know from your last test, the one that you just got back today, I'm going to draw a red box and I'm going to erase it. But inside this red box is a subtraction problem because you know that's what the next step is. That little 4th grade example thing that we did before reminded us that the next step is to subtract, right? So I want you to take a look at something here. If I take, and you can write this down if you want or not, because there's a quicker way to do this. I'm just trying to make this make sense. So if I take the 2 things on top, the x to the third plus 12x squared, and I subtract the purple things, x cubed plus 4x. Do you remember what we learned on the last quiz about how we subtract two polynomials? What's important that we do? Here, let me use some parentheses to show you. There's this guy, and there's this guy. And you know we're supposed to now do this minus this. What do we do, Micah? Say it. Nice job. So this is x to the third plus 12x squared minus x to the third minus 4x squared. So to make my life a little bit easier, right here where these purple things are, I'm going to distribute my subtraction sign, and I'm going to turn this one into minus x to the third, and I'm going to turn this one into minus 4x squared. Because if I'm going to subtract this purple stuff, I have to subtract all the purple stuff, and that means I got to change all the signs. Good so far? We're one step away now from resetting the algorithm back to the beginning. I'm going to draw this little line here, and I'm going to subtract. What is right here where I'm moving my pen, my cursor, what is x to the third minus x to the third? It's gone. That's the whole point of what we just did. And then when I take 12x squared minus 4x squared, I get 8x squared. And now where are we in the algorithm? We're almost there. We're like 2 steps from the finish line. Drop the 37x. Because you know that's what comes next in the process, is to drop the next guy in the queue. So I'm going to bring the plus 37x down, and I am pleased to report that we are back to the beginning. So we have now reset the process completely. And now I'm going to switch colors. I don't care if you like them. I'm not interested. This x, I want to know what I'd have to multiply him by to turn him into this. I want green to make green. 8x. I need to multiply that green thing on the outside, this guy, by 8x to get it to become 8x squared. Good job. What's the next step in the algorithm? Take your 8x and distribute it now through the purple parentheses. Okay, remember the purple parentheses from a few minutes ago? So let's take the 8x on the outside and multiply it through. We should get 8x squared. And watch this. Nice job. I want you to notice something, and this is why I told you we're not going to go through all that. I know I got some weird looks when I was talking about that minus thing a few minutes ago. All you have to do to account for the fact that we have to subtract in the next step is just change all the signs. So like when I'm multiplying this 8x up here, let me show you with some yellow arrows. When I was multiplying this by this, what is the answer to that big yellow arrow? What is it? What's 8x times x? 8x squared. Notice I wrote minus 8x squared. That's because subtraction demands that I'm going to have to change the sign anyways, right? Now take a look at this red arrow, or no, purple arrow right here. What is 8x times positive 4? It is. It's positive 32x, but I very willfully wrote it as minus because subtraction is going to have to happen anyways. The moral of, don't keep racing ahead of me. The moral of the story is that I have to change signs as I go to account for the subtraction. Foxy, okay, bud? All right. Now it's time to get ourselves back to the beginning of the algorithm. We're going to put a little dumb line. We're going to cancel those out. And it's 37x minus 32x is 5x. And the next step is to drop the remaining guy in the queue, and that is a plus 20. And we are now, for the third time, reset back to the beginning of the algorithm. And I'm running out of colors, but here, I can take this x and circle him in red and ask you for the third time now, what do you have to multiply that by to turn it into that? 5. So I head up into my quotient now, and I stick a 5, a positive 5, up there like that. And what do I do with that 5? I distribute it through the divisor, right? What is 5 times x through the divisor? 5x, which I will switch, you're right, to negative or minus 5x. Just change your signs as you go and your life will be simpler. And what is 5 times 4? 20, which I write as minus 20 to make the switch. And as I promised, there is no remainder. Because now if things go well, those cancel. A remainder of 0 means that we had a nice, beautiful divisibility sort of relationship. So the answer to this problem, like when you get to this on Delta Math, the answer that you'll type in is in that green box. What do you think? The first 5 minutes of that, there's no way around it. It's an absolute disaster.
That was 5 minutes.
The first 5 minutes of that process we just went through, there's no way around the fact that it's a disaster. You should have, though, felt yourself feeling better as the last 5 or 6 minutes pressed on. Like, okay, I'm seeing now that this goes into this and multiply. So let's do another one and try to get even better. So our divisor is 2x plus 3. Our dividend is 6x cubed plus 17x squared plus 14x plus 3. So we want to keep everything as simple as we can, and I, through the use of this magical digital new age pen, can highlight just what I want you to see. How does that yellow become that yellow? What do you have to multiply outside yellow by to make inside yellow? 3x squared, though, Haley. We need that extra x to turn that 1x up into 3 of them, right? Good job. So we're going to multiply by 3, and we're also going to multiply by another x squared. And what do we do after this? We distribute down into the divisor. So I'm going to put some purple parentheses back in there, and I'm going to put them around my divisor. So you remember that we're distributing into that guy. And as we go, we're going to change our signs so we don't have to talk about negative distribution and all that. So what is my first portion of this answer going to be? Negative 6x cubed. And the next one, you're fine, buddy. The next one, minus 9x squared. And then you draw your dumb little line. And if this thing that I'm canceling out right here with that big white x, if that doesn't cancel, then you literally missed the whole point. Because the point of long division is to chip away through that dividend. And if you're not knocking part of it off, you're wasting your time. So we've now knocked it down a degree, and let's press on. What's 17x squared minus 9x squared? So 8x squared, and then next up is, so plus 14x says, put me in, coach. I'm ready. And we start over. So again, to color code this for your educational convenience, my question to you is, how does green circled thing become green circled thing? We always just focus on those front tips. Okay, what is the answer there? I need a 4x. I don't even need the squared this time, just an x. And now we distribute through the purple parentheses, change the signs as we go. What do we get? Good. And so I'm going to put it in as a minus 8x squared. And instead of a 12x, I'm going to put it in as a minus 12x. Nice. And then I'm going to cancel out the part that I mean, this doesn't cancel because we're lucky. It cancels because we made it cancel. Right. So those cancel. And then we add together what's 14x and negative 12x. And then we bring down the 3, reset. Correct. And I chose this example for this exact reason right here, this moment in time. When I go red, when I ask you, how does red become red? Micah hit the nail on the head. You can't say, oh, I don't have to change it. You have to say, I multiply it by 1. Good job. Ones are really important in a case like this. The question isn't, what do you do to it? The question is, what do you multiply it by? Hence the 1. And now when we distribute this through, we really don't have to change anything. When you distribute a 1, go ahead, Foxy. Yep.
Minus 3.
That's it. And of course, yet again, as advertised, no remainder. So what I type into delta math is in this yellow rectangle here. Now, there's a part of me that wants to just stop, but what I want to do is get this job done. So we're going to do 2 more examples today. Do you need a break real quick, or are you okay? I'm going to introduce, you're going to see right away, you're good. You're going to see right away something that you did not see in the last 2. Do you want to guess what it is?
More numbers.
No remainders today, promise. What? Yes. If you go back and look at the previous 2 problems, everything that I've written so far and the dividend and the divisor has all been positive pluses. I'm going to change that now. And it's going to add just a little extra level of difficulty and missability. So let's do this. So for our third example, our divisor, let's do, you know what, I put these in the wrong order. I'm going to call an audible on myself and do this one next. I think I had it wrong. So let's do this one. X minus 1 is our divisor, and our dividend is 5x to the third plus x squared minus 15x plus 9. And by the way, just because there's a negative in here, the process, the algorithm is still unaffected. I'm going to keep doing my colors until today is over. So I ask you again, I see you're copying it down, I understand. But when you're ready, you can answer, how does yellow become yellow? What do I multiply outside yellow by to make him inside yellow? Haley? Nice job. And now I find myself distributing through the purple parentheses, changing signs on my answers as I go. You see why the basics are so important. That stuff we practiced on that last quiz, why it's so important. So go ahead and distribute through. What do you get first? Good job. Way to you just keep changing your signs, and I appreciate that. Yeah, so I'm going to put minus 5x cubed because I'm changing. Watch out. What's the next one? Plus 5x squared. And I'm going to show you with a green arrow right now. Follow this big fat green arrow because I got to have a conversation with you. That red thing says 5x squared. And when you multiply it by -1, what do you get? You get negative 5x squared. But what do we do every time? We have to change the signs as we do this step. Look at my green arrow, Foxy. Do you agree that the answer to that green arrow would be negative 5x squared? But I got to change it because I'm doing subtraction. So instead of writing the actual answer, negative 5x squared, I wrote it as plus 5x squared. Do you see it, Boxer? The answer to this problem, oh gosh, I got to be consistent with my colors. The answer to this, I hope you agree, is negative 5x squared. But anytime I'm inserting answers into this line, I always change the sign. Just like here, and you even did this first one for me. Follow big fat yellow arrow. You did this first one for me right here, and you even said negative 5x cubed, didn't you? The answer to my big yellow arrow is positive 5x cubed, obviously, but you knew to make it negative because we changed the signs. So I'm telling you, if you can change a positive to a negative, we can change a negative to a positive. Are you any better on that? Does it? Fan-stinking-tastic. That's great news. All right, we're back. So now it's time to draw my little line and do the little thing, cancel these out. You get 6x squared, drop the next dork in the queue, and we begin again. The question becomes, how does greenie become greenie? We multiply by a positive 6x. Nice job. And now we take that positive 6x and we distribute it through the purple parentheses, changing the signs as we go. So what's my first answer going to be? Negative 6x squared and plus 6x. Would have been a negative. We swapped it. Cancel those out. Pray to God that we know how to add basic numbers. Good job, Micah. Negative 15x plus 6x is negative 9x. Drop the next guy in the queue, plus 9, and we are back to the start line. Third verse, same as the first. My question again to you is, how does this red guy become this red guy? That question will always be there. We multiply by negative 9. And as we distribute the negative 9 through the parentheses, we change the signs as we put our answers underneath. And I'm running out of room. So negative 9 times x would be negative 9x, not us. We're putting plus 9x. And negative 9 times negative 1 would be plus 9, not us. We're putting minus 9. And you can see, again, no remainder. I'm going to put one on the board, and I'm going to give you about 5 minutes to try it all by yourself. And then I'm going to work through it with you, and then we're going to be done today. We're not going to get into Delta math. We're not going to work. Tomorrow's going to be our worky day. Got it? Okay. If you get this one right, I will be impressed. Okay. Not that maybe any of you care about that, but for what it's worth. Oh. It's not easy. That's a 23. It's kind of attached to it. That's my bad. So I have inside, I have 12x to the third minus 23x squared plus 19x minus 6. And I'm going to pause the recording for 5 minutes while I give you guys a chance to work. I don't want an awkward 5-minute lapse in there. So 3x goes into that, exactly 4x squared times. And I'm going to go a little quicker here. So when I multiply through, I'm going to multiply and change my signs. That would be 12x to the third. It's minus 12x to the third. That would be minus 8x squared. I'm putting plus 8x squared. Cancel, add, here we go. That's negative 15x squared. Drop the next guy in the queue and begin again. And again, in keeping with my color theme, I'm going to ask you now, how does green guy become green guy? And the answer is I multiply him by negative 5x. So I need a negative 5x to make that happen. As I now distribute through, sorry for the lack of consistency, I forgot my purple parentheses. As I distribute down through my purple parentheses, I write answers with signs changed. So it would be minus 15x squared, not this guy. I'm putting plus, and that would be plus 10x. I'm putting minus 10x. Once this clicks, then you'll be ready for the next lesson when we start doing more difficult problems. So that's what the next today and tomorrow are for, just driving the skill home. Cancel those, add them together, you get 9x, drop the next guy. And then the question is, how does red guy multiply to become red guy? And the answer is times 3. So I stick a plus 3 up in my quotient, distribute it through, changing the signs as I go. And that is 3 times 3 would be 9, not this guy. That's minus 9x, and 3 times negative 2 would be minus 6. So I'm putting plus 6. Everybody cancels, and the answer is up here in the yellow box. Again, no work time today. Don't worry about it. Don't sweat it. The assignment will be on Delta, but don't even acknowledge that it's there. It's fine. Yeah, we'll work on it tomorrow. Whole period, okay? Yeah, right.